So I will briefly present the corpus of works treated during the two phases of the Rijksmuseum pastel project between 2007 and 2013, but not continuously. Their technological study, the damages and conservation treatments achieved. I will mainly talk about dry cleaning and flattening, and I will then briefly mention the reframing and monitoring of the pastels. The Rijksmuseum houses the largest collection of pastels by the Swiss artist Jean-Étienne Lyotard, after the Musée d'Art et d'Histoire of Genève, with 23 pastels. They were studied between 2007 and 2013, together with the 9 portraits of the Dutch royal family by the German artist Johann Friedrich Tischbein. After for the questions. In 2007, I went a little bit too fast. Well, I can stay here. In 2007, the head of the paper conservation studio, Peter Poldervaart, initiated a conservation project in order to take care of the 18th century pastels that would be exhibited after the renovation of the museum. Having worked on the conservation and framing of pastels during my master thesis, I was invited to take part in this project, initially co-financed by the Carnot Foundation. After the departure in 2007 of Peter, the project was continued under the supervision of Idelette van Leeuwen, new head of the conservation studio. It also involved the contribution and collaboration of Leila Sauvage, first as an intern and later as a colleague, of the colleagues from the conservation department, photographers and scientists from the Rijksmuseum. It eventually involved many exchanges with colleagues from various countries working on pastels, and collaborations with scientists from the Dutch Agency for Cultural Heritage. So, since their arrival at the Rijksmuseum at the end of the 19th century, Lyotard and Tischbein pastels have always been exhibited in the museum and therefore subjected to very changing environmental conditions. As they were taken out of their framings, it was a very unique opportunity to thoroughly document them and study them with a condition report made on purpose. All paper reports from former conservation treatments were compiled. 2 major conservation campaigns on pastels indeed took place in 1957 and in 1977, consequently, to a water leakage in the heating room that took place in the heating room next to the former pastel storage in the historic building. Photographic documentation, including photographies in raking, infrared and UV lights, helped visualize deformations in the support under drawing mold spots and foxings. To study the pigments and reconstruct the artist's palette, Extra F, macroscanning Extra F, Raman and FTIR were used. The scientist Julia Schultz attempted to characterize Lyotard fixatives using the antibody-based technique ELISA. Supports were also studied. Lyotard made pastels on blue paper and used very unusual supports as a prepared canvas or a wooden panel, as you can see here. But parchment was his favorite support, also used for his pastels by Tischbein. They were all stretched and attached to a strainer. Some strainers that had been damaged by insects were replaced by ply or pressed wood panels, as you can see at the bottom of the image. All the framings had already been modified when we opened them. Zinc plates, pressed and plywood were used as backing boards. Many modern self-adhesive sealing materials were used to close them. They had aged and were becoming loose, leaving some backing boards or glazings unsecured. Framing systems had therefore become leaky, allowing humidity, dust and insects inside. Here is you can see on the top right picture a cotton, the color of the cotton after cleaning the black, greasy, sooty dust inside the glass. The most frequent of the climate-related damages were mold spots, clearly visible in UV lights. Mold growth was triggered by condensation, humidity trapped between the glass and the surface of the pastel. Brown spots were also visible on the parchment, as in the example at the bottom. They were caused, in this case, by the oily anti-rust lead paint formerly applied in frame rabbets on the zinc backing boards. It became powdery and migrated also on the pastels. In order to clean dust and mold, pastel pipettes were used attached to a vacuum cleaner containing a HEPA filter, 14, with several suction control points. A few hairs are attached to the end of the glass pipette, as you can see on the photo. They help to grab mycelium and to keep some distance from the pastel layer. The transparency of the pipette also helps monitoring the pastel layer cohesion and adhesion. The amount of pigments sucked in the pipette is an indicator of how loose they are. And then the distance and the angle of the pipette is consequently adapted during the treatment. The more the angle is closed and parallel to the surface, the less it endangers the pastel layer. So this method enables to work quite well, very locally. Climate fluctuations also had an impact on the pastel supports, particularly thin parchment. They cause dimensional changes, tensions, cockling and tears. Because of humidity, nails holding parchment to the strainer corroded. In some cases, corrosion migrated in the parchment, which was mechanically weakened and detached from the strainer. This is actually what you're seeing here. If you look at the left, on the left of the pastel, you can see that some nails are missing, and yeah, the parchment is coming off, is detaching from the strainer. During the conservation campaign I talked about in 1977, stainless steel pins were used to secure and prevent parchment from detaching further. You can see them if you look at on the same side, on the left, the glimmering pins are visible. They were somewhat effective but could not stop further deformations and caused in some cases new tensions, resulting in tears, as in this other example, top left. Tensions are indeed more important in the corners. So in the portrait of Lady Tyro, the deformations on both sides of the portrait created heavy distortions in the face. The pastel had to be stretched and secured back to the strainer. It was not entirely detached from the strainer in order to keep the benefit of the existing tensions, and because the parchment had remained flat in the lower part of the pastel. So one side was treated after the other. The fiber strips of Japanese paper were attached about 5 mm after the fold mark on the verso of the parchment using starch paste. When the access between the parchment and the strainer was difficult, mylar strips were used to slip the Japanese paper strips. The pastel was then secured in an easel. The top part of the easel being used as a press to dry the strips. The pastel was then put in a small wet room at 65% relative humidity for about 4 or 5 hours. The parchment could then relax entirely, and a more local humidification was applied with an ultrasonic mister on the side in order to relax the thick lamination of parchment, glue, and paper. The paper strips were then gently pulled and attached back to the strainer with starch paste. A hot spatula was used to accelerate the drying process. So on the right, you can see both sides of the pastel after treatment. So here is the result. So it's better, not perfect in one angle, but yeah, some kind of improvement. This is another example This is the portrait of my Lyotard Farg. It's the largest pastel parchment of the Rijksmuseum. It is more than 1 meter height. It is painted on two pieces of parchment stretched on 3 sides and pasted to a stretched canvas. A thin piece of parchment, strip of parchment, hides the area where the 2 pieces of parchment meet on the front of the pastel. I hope you can see that clearly. It was treated several times. In 1957 against mold. If you look very closely, the top left photo, you will see the mold dots, mold points. They are not very visible, but you can see them. In 1957, the parchment strip was attached back to the support with synthetic glue that fluoresces under UV. This is the central photography. But if you look at the 2012 photo, which is in raking lights, so you can see the deformations better, the parchment strip had become partially loose again, and the top piece of parchment was locally detaching from the canvas, creating uneven tensions and deformations. The piece of parchment at the top had then to be restretched without removing it from the strainer and without damaging the pastel layer. A pulling and pressing piece of equipment was specially designed for the purpose by Idelette van Leeuwen and Nico Lingbeek. It is a reuse of a bookbinding swing frame, adapted to the size of the pastel. Across the machine, a wooden crossbar with a very thin profile enables to press locally on the pastel surface. The pastel was secured with wooden blocks that you can see in the corners, and a transparent lid was built to protect the main piece of parchment at the bottom. So after the removal of the half-loose parchment strip, a Japanese paper strip, a kind of pulling strip, was attached along the loose edge of the parchment with starch paste and pressed. A wooden block had been placed under the pastel in order to support the pressure. It was not pushing in the void. Then an open humidity chamber was made using an ultrasonic mister, mylar and cardboard to humidify the top piece of parchment while the bottom was still protected under the lid. After a few hours at maximum of 80% relative humidity, the pressure of the crossbar was released, allowing to pull gently the paper strip downwards parallel to the pastel surface in order to flatten it. So I hope it's clear in the drawings. See which piece of paper was pulled. Pressure was applied again on the parchment and paper seal with the crossbar to maintain that new tension. So then the parchment was left to dry very slowly under mylar foil. That's the photo you can see on the right. A thermohygrometer helped monitoring the various steps of the humidification and drying processes. The distance, after a few days, the same pulling strip was glued back to the other parchment, to the lower parchment piece with starch paste and pressed again. And after drying, the pressure was released and the pastel was left to stabilize for a couple of days. The excess of paper was cut with a scalpel and the parchment strip was glued back with starch paste dots. So that's the pictures you see on the left and the result. Several types of conservation framing systems were used to reframe the pastels, both breathing and airtight. Top left, breathing framing box made with conservation board, Tyvek glued with Ivacon R. Tyvek protects from dust and liquids. Top right, the same type of boxes were made, but they were made airtight using Marvel Seal laminate. The choice of an airtight system was made in order to limit as much as possible humidity fluctuations within the microenvironment between the glazing and the pastel layer to prevent risks of further climate damages as mold growth. It seemed to be a better choice also after the research made together with the RCA scientist Bart Ankersmit. When the frame rabbet was too small, no boxes could be made. An airtight framing was, normal airtight framing was made using thermosealed marble seal, a polycarbonate backing board, and using plastazote foam 2 mm as a seal in the rabbet, so between the glass and the rabbet, and at the back of the frame. That's the lower photos. So 9 pastels by Lyotard and 9 pastels by Tischbein were treated in total. Most of them are now exhibited in the museum. The various systems, framing systems, are being monitored with I-button mini data loggers put in several framings. They can be, those mini data loggers can be programmed and read using an USB reader, and data can be converted in an Excel sheet. Sorry for the mistake in German. Merci.